So today's lesson is simplifying radical expressions. And instead of me stopping along the way to get feedback on how well you're understanding it, you're going to do a little activity at the very end that shows me where you're present in class. It allows me to take attendance, and it also gives me a little feedback on which type of problems do I need to start on Thursday with as a review. Okay, now it's going to be very imperative that you know in your notes where to find this table. And if you've been lazy and you haven't created this table, now is the time to do it. All right, so how do we do this? Our whole goal is to rewrite and simplify equations that have radicals or rational exponents. In my opinion, the more problems you practice, the better you're going to get at this. Like most things, the more problems you practice, the better idea you'll have on how do I enter this problem? What is the entry point? So this exponent on the outside needs to be applied to both items inside, both the negative 64 and to the x to the negative 6th. Now it came from parentheses, it must remain in parentheses. And I'm going to start with the negative 64. It doesn't matter which side you start with, but I'm going to start over here. So to do this, I first am going to apply the bottom number. And remember, a common mistake is to write it like this. As we've talked about last week, we're going to put a 1 over that nth root. So I'm going to go to the column that has a 3 and see if I can identify just a 64. The column that has a 3, oh, there's the 64. I go straight across. It evaluates now to a 4. Now I know that 4 times itself 3 times does not equal 64. But negative 4 times negative 4 times negative 4 3 times does equal negative 64. As a reminder, an odd number of negatives when you multiply or divide gives you a negative. So this evaluated is equivalent to negative 4. And now I need to take negative 4 to the 4th. That means negative 4 times itself 4 times. If you're a visual learner like myself, I'm going to write it out 4 times. Then I'm going to use this table. I'm going to find 4, and I'm going to go across 4 places. So here's 4 to the 1st, to the 2nd, to the 3rd, to the 4th. Now how do you know if it is positive or negative? An even number of negatives when you multiply or divide, an even number of negatives gives you a positive answer. Okay, coming back up here, I have 4 over 3. So I'm going to take that fraction and I'm going to distribute it. When you have a power to a power you multiply, a common misconception is this negative 6 should be multiplied times the top and bottom. Not true. It only gets multiplied by the top. Negative 6 times 4 is negative 24. 1 times 3 is 3. When you divide, you end up with negative 8. Now in our final answer, after we've reduced things as far as possible, we do not want a negative exponent. And for that reason, if we have a negative exponent, it says, hey, I'm not happy here, and I'm on top, but when I go to the bottom, now I'm happy. This is the reduced form of number 1. Going on right now to number, I'm actually going to skip across and go to number 7. It'll just be easier here for filming this. When you have the same nth root, and you may be looking and going, where's the nth root? I don't see a number. Remember that when you don't see an nth root, it's a hidden 2. So when you have the same nth root and you're either multiplying or dividing, you get to do this little trick. We get to put them underneath the same radical. So 245 divided by 5. So it's underneath the same radical because it's the same nth root. Then afterwards, I'll apply the negative 5. So normally I would jump into Desmos because that's what you're going to most likely be using unless you have a graphing calculator. But for the purpose of today, knowing that I only have 30 minutes to get through this lesson, I'm just going to use a graphing calculator. 245 divided by 5 is 49. So I can rewrite this as 49, and then afterwards I'll apply the negative 5. I'm going to go to column 2. I'm going to find the 49. Column 2 and find the 49. Column 2, find the 49. Okay, it's there. Now I'll go straight across, and we can see it's equal to 7. So this inside portion is equal to 7. As I said before I started the video, for many of you it may be helpful just to watch me simplify each problem, and then for you to go back and watch the video and write it down in your notes. How do we do this? Well, this is 2 parts. The negative sign says, hey, move it. If it's on top, go to the bottom, or if it's on bottom, go to the top. The 5 is different. 5 says take 7 times itself 5 times. 7 times itself 5 times. So I'm going to find the 7. Here is the 7. There's 7 to the first, 7 to the second, third, fourth, and fifth. So I'm going to write this number down. Misconception here is a lot of times students think they should just make it negative. Nope. I took it to the fifth, and this is the number I got, and now this negative sign means if it was on top, put it on the bottom. This is the final answer for number 7. I'm going to go on to number 8, so it's on the side. Now, like number 7, when you have the same nth root, I get to multiply or divide accordingly. Well, here, instead of having an nth root, it's to the 5th power. When you have that same exponent, and I'm multiplying or dividing, I get to do the work. So 27 divided by 3, and then I'll take it to the 5th. And when I'm done with that, I'll apply this outside. So I know 27 divided by 3 without using a calculator is 9. Now here happens to be a situation where there's more than one way to do this, and my mind always is like, what's the quickest way for me to get the answer? What's the least amount of work? So I could apply the 5. I could go 9 times 9 times 9 times 9, and then I could apply this afterwards, and that would work. That would totally work. Or you may recognize that exponent rules say when you have a power to a power, you get to multiply. So 5 times negative 2 is negative 10. 1 times 5 is 5. This reduces to 9 to the negative 2. And just like we had 7 to the negative 5, just like that same concept, this says, forget about this negative sign for a second. And this says take 9 times itself twice. Well, I know 9 times 9 is 81. The negative sign says, hey, if it's on top, move it to the bottom. Or if it would have been on bottom, move it to the top. Done. Although I said this, can I have you, as I get ready to do problem number 2, can you go into the chat for me, and can you give me right now a thumbs up or thumbs down based on your understanding of the first 3 problems I did? Okay, I'm going over right now to number 2. I had some of you that reached out to me and said, problems like this really confuse me. Okay, we're going to do a few more like it. We'll do 1 today, and we're going to start off class actually, or 2 today, and we're going to start off class on Thursday with a few more like it to review. So here we go. So I'm going to use this analogy that this is the door, and we're going to call this bouncer. Now this is bouncer number 5. And so negative 32 comes to the door and says, hey, can I get out here? And this doorman says, just a second here. And so I'm going to go into the column with a 5, and I'm going to see, can I find a 32? I'm going to go into column number 5 and see, can I find a 32? So here's column 5, and here's a 32. Forget about it being a negative right now. It's just 32. Go straight across, and I can see that it evaluates to be a 2. So if I do 2 5 times 2, 2, 2, 2, and 2, I know 2 times 2 times 2 times 2 times 2 is 32, but I don't want a 32. I want a negative 32. Notice that if you make these negative, again, 2 times itself 5 times is 32. Awesome. And because there's an odd number of negatives, specifically 5 negatives, and since there's an odd number of negatives, it means your final answer would be negative. So when negative 32 comes to the door and says, hey, can I get out? Yep. The storeman says, yes, you can come out, and you're evaluated to become a negative 2. Now there's more than one way for me to explain how to move these outside or simplify them. And if you have a simpler way, great. I'm just showing this visually for those that may learn best by seeing. So 8 comes to the door and says, hey, can I get out? And the doorman says, just a second, there's 25. I have to do them in groups of 5. So 1 group, 5, 10, 15, 20, 25. Yep, you can get out. Now how many can get out? 1, 2, 3, 4, 5. 5 fulls. And B comes to the door and says, hey, can I get out? And the doorman says, just a second. Has to be groups of 5. 5, 10, oh, and there's 2 left over. So the doorman says, I'll let 2 of you out, but the remaining must stay inside, and there's 2 remaining. Now C comes to the door, and C says, can I get out? And doorman's 5 says, no, you don't even have a full group of 5. You have to stay in. And D comes to the door. D, the first, comes to the door and says, can I get out? And he says, no, you don't even have a full group of 5. You need to stay in. This would be my final answer. Oftentimes students forget to put the nth root up here when they rewrite it. This is the final answer. That's a tough one. Can I either right now a smiley face or a frowny face if you understood the explanation? I know I used kind of a goofy analogy. Smiley face or frowny face, just giving me that feedback. Number three, okay? So again, as long as we're only multiplying or dividing, as long as we are only multiplying or dividing, when you have the same exponent, we get to do the work. So I'm going to grab a calculator, and I'm going to write this as 192 over 3, and they both have a 1/2. We could never do that unless they both had the same exponent. So 192 divided by 3, let's see what that is. 192 divided by 3 is 64. Okay. So this inside part is 64. So I have 64 to the 1/2, and then I'm going to raise it to the -3. So I'm going to go into, on our little table, and I'm going to find a 2 and see, can I identify a 64? Here's my 2. I go down to 64 and go across, it's 8. This portion evaluates to 8. Now, just like the first two, problem 2 and problem 3 that I did today, remember, forget about this negative right now. This means 8 times itself 3 times. And we can use our table to quickly do that. So here's 8 to the first, to the second, and to the third. So it's 512. That's 8 times 8 times 8, 3 times. And now what do we do with that negative sign? It does not mean I put a negative here. It means if it was on top, it now goes to the bottom, or vice versa. Done. Okay, I'm going to go on to number 9. Number 9 is just like the first problem we did today. So number 9 is just like this very first problem today. I need to apply that outside exponent to both things on the inside. So I have a -1/2 that's going to be applied to both. So I have 144 to the -1/2 and x to the -14 to the -1/2. And it doesn't matter if I do the left side first or the right side. It makes no difference. Like for instance, I can do the right side first. An exponent to an exponent, I get to multiply. Well, two negatives, an even number of negatives, that's hard to say, gives me a final answer that's positive. And when I multiply straight across, 14 times 1 is 14, 1 times 2 is 2, and that is going to reduce to 7. So the right side gives me x to the 7th. Now, what does the left side give me? Well, let's forget all about that negative sign, because that just often throws the students off, and then they get confused. Should something give you a final answer that's negative? It's very confusing for most people. So let's forget about the negative right now and just think of the 1/2. 144 to the 1/2. That means look into the column that has a 2 and see, can you identify a 144? Notice these are perfect squares, just like these are perfect cubes. I achieve these by going 1 times 1, 2 times 2, 3 times 3, 4 times 4. And although my table stops at 100, that doesn't mean it actually stops. Here's 11 times 11, 12 times 12. So 144 is the same as 12 times 12. So 144 to the 1/2 is 12. And now what about this negative sign? That just means if it was on top, it must now go to the bottom. So 1 over 12, the 12 has to go in the bottom. This remains on top. We never had to move it to the bottom. Do I have to have a 1 on top? No, because it's x to the 7, it's not necessary, which means you could also rewrite it like this. Before I go any further, we are halfway done. I need you to be really, really honest right now with your radians right now. Can I have not your ability to try these on your own, just your ability to understand the explanation? Can I have a 1 through 5 on your ability to understand right now? Never feel embarrassed to give me a 1 or 2 if that's where you're at. Okay, so this problem looks really confusing to students because there's these large numbers and there's fractions. So let's break this down over here. And if I said to you, what's x to the 9th over x to the 7th? I would hope that the majority of students would go, oh, okay, when you have the same base and you're dividing, that means I subtract. And I subtract always the top minus the bottom. So this expression would simplify into x squared. That same concept gets applied over here. The same concept gets applied. So when you have the same base and we're dividing, I take the top and I subtract the bottom. Now I would generally go into decimals, but just for the purpose of time, we can get the same answer here. So I have to use parentheses. I have 15/4 subtract 71 over 20. And remember, whenever I get a decimal, I'm going to turn it back into a fraction. You can do that in decimals as well, and I end up with 1/5. So this becomes 32 to the 1/5. Now, am I done is the question. Well, here's how you can check. So I go to column 5, it's that bottom number, column 5, and see, is there a 32? Here's column 5. Oh, there is the 32, and that is equivalent to 2. Final answer, 2. This whole thing here that's really overwhelming to look at actually simplifies simply to the whole number 2. Remember, when you have the exact same nth root or the same variable, the same exponent, in this case it is a hidden 2, and as long as you're multiplying and dividing, you get to put them together. So I'm going to make a really large radical, has to keep with that same nth root of 2, and I get to write 8 x to the 6th y to 24 over 2x squared y squared. Okay, now I get to do the operation. 8 divided by 2 is 4. And just like I did the problem over here, when you have the same base and you're dividing, you get to subtract top minus bottom. 6 minus 2 is 4. 24 subtract 2 is 22. Now we can't stop there. We have to look into the column that has a 2 and see, can I evaluate the 4? Now, do you have to keep doing this? If you can start to figure out some of this in your head, that's fine. This is just a way to check. So column 2, I find the 4, it evaluates to a 2. So 4 says, can I get out? Doorman says yes. You evaluate into a 2. And then the 4 comes over, x to the 4th says, can I get out? And he says, yes, I can write two groups of x squared. So 2 groups get to come out. 2 groups get to come out. Okay, and remember, if you add these up, it needs to equal this number. And then y to the 11th, or y, excuse me, to the 22nd come over and says, can I get out? Doorman 2 says, and I'm not going to write them all out, but it'd be 2, 4, 6, 8, 10, so on. And we get all the way to 22, and there'd be 11 groups. That's the simplified answer. Simplified answer. Getting down there, not too much left. This is just like the first problem we did today. Remember, the 3/2 has to be applied to both items inside. That's often forgot about. So 81 to the 3/2 and -6 to the 3/2. Whether you do the left side or the right side, it does not matter. We're going to be done here in the next 5 to 6 minutes, so hold tight. So I'm going to start over here. Now, how do I actually go about doing this? We always take care of the bottom number first. It's not just 2, it's 1 over 2 when we rewrite it. So if we multiplied here, we'd still end up with 3/2. Now, to evaluate this, I look into the 2's and see, is there an 81? Here's the 2's. I go down to 81. Oh, it's there. And the answer is 9. So this gives me 9, and then I need to take 9 to the 3rd. That's not 27. Remember, that's 9 times 9 times 9. If you don't know the answer, you can come over to your table, 9 to the 1st, 2nd, 3rd. So this portion evaluates to 729. Now, what about the second portion? Remember, an exponent to another exponent, we multiply. So this is going to give us -18 over 2, which reduces to -9. Now, x to the -9, it's not happy. Does this entire thing have to go to the bottom? No. This part is happy. It's this portion that's not happy. So when I rewrite it, 729 stays on top, x to the 9th goes to the bottom. Problem is simplified. Number 11 was a problem you learned how to do on Thursday of last week. Remember, any answer we have, we don't want to have a final answer that has a radical in the bottom. It's not proper. So this must be applied to both the top and to the bottom. Hold tight, we're almost done. And now if I look into column 4, I can see there's no 2 there. Column 4, there's no 2. 2 would be right here and it doesn't even exist. So I'm going to go one by one as I work myself down, and I want to ask myself, can I take 2 times a whole number and get this next number? Like, for instance, 2 times something does equal 16. If it doesn't, I go to the next one. 2 times a whole number does equal 81, and I keep going until I find the first number. Well, I happen to be lucky. I know 2 times 8 is 16. 2 times 8 is 16. I want to somehow make the bottom into a number that's in this list. Why in this particular list? Because it has a fourth root. So to get to 16, remember 2 times 8, and whatever you do to the bottom, you must also do to the top. Now when I rewrite it, 1 times 8 is 8, 2 times 8 is 16, and that's where I can identify the 16 in this column and go, oh, that evaluates to a 2, and now I no longer have a radical in the bottom. It is really common for students to do all this great work and then they give me a final answer and they think they can reduce this further, and they go 8 divided by 2 is 4. Okay, can't combine these. They're not like terms. This has a radical, this does not. They're not like terms. That's the final answer. 2 problems left. Hang in there. Again, when you have the exact same exponent, I get to keep it and I get to do the work on the inside here. So 54 divided by 2 is 27. Same base dividing, I can subtract 25, subtract 1 is 24. And 34 subtract 4 is 33. And now ask ourselves, do we know a number we can take times 3 and get 27? That's what it's saying. Or you can use that silly analogy where 27 goes to the door and says, can I get out? Well, let's look. Let's look into the column 3. Oh, 27 is there in column 3. It evaluates to be a 3. So this gets to come outside. It evaluates to be a 3. Then X comes and says, can I get out? And 3 says, just a second. 3, 6, 9, 12, 15, 18, 23, and 24. And if you count them, there's a total of 8. So 8 full groups get to come out. 8 full groups get to come out. Same thing here. When Y comes over and asks them to come out, there's exactly 11 full groups that get to come out. Now, how can we check that we did that right? Because 8 times 3 is 24, and 11 times 3 is 33. Very last problem for today. Well, if you're pretty good with your basic multiplying, you can see that you can actually already reduce this. If not, you could go into Desmos if you weren't sure, and you would take 7 divided by 56 and then turn it back into fraction, and you're like, oh, it does reduce. I'm sorry. It does reduce to 1/8. It does reduce to 1/8 before I even get started. So this is 1 over 8 to the negative 2/3. Now, how do I do this problem? We always apply the bottom number first. Always apply the bottom number first. So it's going to be 1 over 8. I'm going to apply the 1/3, and then afterwards I'll take care of the negative 2. So in the 3 column, is it possible to find a 1? In the 3 column, is it possible to find an 8? Let's check. Let's go to the 3 column. In the 3 column, I can find a 1, which evaluates to 1. In the 3 column, I can find an 8, which evaluates to 2. Stay awake, we're almost done. Remember, as I spoke about earlier in this lesson, let's forget about the negative. So 1 squared, that means 1 times 1 is 1. 2 squared, 2 times 2 is 4. Now when we apply this negative sign, it does not mean I put a negative down in front or in top or the bottom. It means I need to switch something. If something was on top, it now goes to the bottom. If it was at the bottom, it now goes to top.